This video is all about materials in 3D rendering. And materials are what allow you to turn this into this. In other words, materials define how things look, which we call their material properties. And materials tell us how objects look under different lighting conditions, how objects appear when you look at them from different angles, and so on and so forth. And we're going to talk about how materials work in 3D rendering, but let's start by exploring some real-world material properties. Let's take something interesting, like this interesting textured wall in this modern decor room. So if we were to describe the properties of this wall, we'd likely start with its color. It's some shade of white or maybe light gray. The next thing we notice is that the wall has some depth to it, some bumpiness. We might also describe how the wall reacts to light. It's not very shiny or reflective or metallic, it's a pretty flat color, or maybe a matte color. And looking around this room, we see that every object is very different. Speaking of shininess, the chair is quite shiny, and you can see some light and some dark highlights on it. And the faucet isn't just shiny, it has a mirror finish, and it actually reflects the room around it. And what about the floor? Unlike the wall or the chair or the faucet, it's not a single solid color. It has some variation. You can see things like the wood grain, and each piece of wood in the floor has a slightly different texture to it. And then finally, we have the glasses sitting on the table. These are both shiny, they reflect the lights, and semi-clear or semi-transparent. And so we have a basic set of terms to describe everything we see in this room. What color is it? Is it shiny or reflective or dull? Is it bumpy or flat? Is it clear or opaque? So we can look at any object in the world, and we can describe how it looks in terms of just a few basic components. And that's how we approach coloring our virtual worlds as well. In 3D modeling programs or in game engines, there are terms for all of these different components. We call the underlying color of an object its diffuse color, or albedo. Now sometimes this is just a flat color, like our wall, and sometimes it's more complex, like the pattern on the rug here, or the colors on the TV. The bumpiness of objects, like you see on that back wall, we call that the bump map or the normal map, and we'll talk a little bit later about why we call it that. The shininess of objects, like you see on the wall, is called the specular. When objects reflect the room around them, that's more than just shininess. You can see that, for instance, on the bottle. We call that reflectivity. And objects that are more clear, like the glasses, are said to have transparency. Or we might say that they have less opacity or less alpha. So transparency and opacity or alpha are opposites. As something gets more transparent, it gets less opaque. As it gets more transparent, its alpha goes down. And by the way, all these properties of the materials, when you're working in 3D, are referred to as channels or maps. So maybe you'll talk about the diffuse map, or the specular channel, or so on. And there are a few other properties of materials that you'll see when you work in 3D. A fun one is called the Fresnel Effect, and you'll see it in things like ripples on the water. So looking at this scene, we notice that in certain parts of the water, when we're sort of looking flat at the ripple, the part of the ripple that's facing us, we see a deep green color. And what we're actually seeing, we're looking down into the water and we're seeing the bottom of the lake. But on the parts of the ripples that are facing almost perpendicular to us, so we're just seeing the edge of them, like you see at the top of the image, you see this weird effect where they're much brighter. And what's actually happening is, due to the surface properties of the water, when you look straight at it, and I'm going to draw this real quick for you, if we just sort of take a calmish lake and we look at our viewing angle of the lake, if our eye were up here, we're looking straight down at the water, and we're perpendicular to the water would appear clear. We could see the bottom of the lake. But if we were to move to the shoreline over here, and we were to look out across the water would be almost 100% reflective. So all you would see on the water would be the reflection of the sky. And that, in a nutshell, is the Fresnel effect, and that's what we're seeing in the ripples on this lake. Which, by the way, isn't just water. You can see it in this glass ball too, how it's clear in the center and it reflects the room around it on its edges. So, getting back to our interesting wall, you'll notice that this wall and the floor and everything else are affected by the lighting of the room. So we refer to these as lit materials. Now, we may also have unlit materials in a 3D scene. And these aren't necessarily something you'd see in the real world, but these are very useful in games and other 3D applications. Unlit just means that something is fully bright regardless of what the lights are doing around it. And then we have in-between materials, which we'll call self-illuminating materials or emissive materials. So, for instance, the fact that you can still see your phone when you're sitting in the dark, we would say that your phone screen is self-illuminating, or your phone emits light. It doesn't matter if the room is bright or completely dark, you can still see the screen. Now, the difference between this and an unlit texture or an unlit material is that self-illumination is still affected by light. So your phone screen is much brighter in the direct sun than it is in the dark. So your phone adds its own self-illumination to whatever is going on around it. Now, with a truly unlit material, it doesn't matter what you do with the surrounding light. It'll look exactly the same in the bright sun or in a pitch black room. And that gives us a pretty good survey of some of the material properties we can expect to work with when we create materials for 3D models, when we work in 3D. So to just give a quick recap, we've talked about a bunch of maps or channels that things can have. And these can be things like the underlying color or texture, things like the bumpiness or roughness of a material. We talked about things like how the object responds to and reflects light, about the transparency of an object, like glass or water, and about how transparent objects become opaque around their edges. And lastly, we talked about self-illuminating and unlit materials. And as you start to work in 3D, no matter what program you're using, you're going to see these same terms, these same material properties, these same channels and maps again and again. In coming videos, we'll take a look at how we can start to set up all these properties on our own materials in a way that's physically realistic, or mimics the way that real physical objects look.